Hello everyone, welcome back to Machine Learning Stack. Welcome to week 5, lecture 2, Data Science in Python and Machine Learning Coding Dojo. Assignments due this week by Friday morning. That is your abalone pre-processing exercise core, pipeline activity, project 1, part 5. For project 1, part 5, you need to make a new notebook. You can reload the dataset again. As I have did this announcement in previous lesson as well. So you need to take care of that thing in for your project 1, part 5 core. And if you all can submit your all assignments before Friday 9 a.m. PST, that would be very good. Okay. And next week, you will get into predictive modeling. Okay. Recap. So what we have covered in the first lesson, we have covered about what is machine learning, what are the types of machine learning, applications of machine learning, what is train and test split, why we split the data set, and what is model validation. Okay. So if I ask, anyone can answer what is machine learning and its type? Anyone? Anyone?
There's supervised and unsupervised learning.
Great. Yes. And any example of machine learning applications?
The one I remember was the stock market predicting
Yes,
prices.
Yes, great. And why we need to split the data set? Anyone?
For train and test?
Yes, we will split it into train and test, but why?
Okay, wait.
To prevent data leakage.
Yes, for the model validation, right?
So there's something to verify when after you've run your algorithm.
Yes, great. Good. Okay, so before moving ahead for today's lesson, we will do 5-minute breakout room activity. Okay, you need to click on this link like this and please answer these questions. Okay, so you will have a 5-minute. So I will open up breakout rooms for 5 minutes.
Oh, where's the link, Nuja?
Here, this is the one.
Oh, it's on Discord. Okay, got it.
Okay, so breakout room. Okay.
Hey Nirja, when I was going to go open the document, I actually hit not now instead of leave room when it popped up because it popped up literally right where I was clicking. So I don't think that I made it into a breakout room.
You should click on breakout rooms and it'll still pop up for you.
Join breakout room. Okay,
Mm-hmm.
okay, there it is. Okay, thanks.
Cool. I'll be joining the activity, so I'll be back.
Hey, Justina, how are you?
got so many things going beep and whir and everything when I have between the laptop and the MacBook and this computer.
Are they able to write
It
in the?
probably would be good to share the link to the Padlet in chat. Many of them probably won't have the
Okay.
PowerPoint presentation up and ready.
Welcome back, everyone. So were you all able to write in the Padlet?
One person in our group wrote, so we all contributed. Yeah.
Okay, but I can't see the answer.
Click the add button at the bottom. Oh, there it goes.
Oh,
I had to click that little arrow to the right of your answer.
okay. Okay.
There we go. Now we're getting some
And now we got all. Good, good. Okay. Okay, good. Everybody is contributing. This is great. Yes. Good. Okay, so let's move ahead. So this is your reading calendar before like you come for the next lesson next week. If you can read this content, what is regression, what are the regression metrics? Okay. If you want to look at the reading calendar, you can click on that and go to the schedule and you will see what you need to read before the next lesson. Okay. So over today's agenda is after this lesson, you will be able to do what is data preprocessing, what is data leakage, what are pipelines and column transformer. Over today's topic is very important, very, very important. Okay. So now, first of all, we will discuss about what is data preprocessing in machine learning, right? If you look at these, we have, this is data preprocessing. I have divided into two parts. Okay. This portion, you can do these steps before data set split. Okay. In this part comes up with the explore data set. The first step you have seen when you are doing the core assignment, you are, first of all, you are importing the libraries, right? And then you are loading the data set, right? Once you load the data set, you want to explore it. How do you explore it? You explore it by using method, right? And then fourth step, we have discussed, this is mandatory to check your missing value, right? And duplicates. Okay. You both steps need to be performed before your data set split. This is mandatory. Okay. So these are the steps before data set split you can perform. It comes under pre-processing steps. But in these steps, we are not doing any data transformation. We are not taking any action on our data set. We are just exploring it, right? So this is a difference. But once you split the data set, you are going to perform these steps. The first one is data cleaning and then data transformation. So in the data cleaning, what you are going to do, if you have already checked, let's suppose the missing value and duplicates you can handle before split. It will not harm your data set. But if you find the missing value, then what you will do here? Then it's a time to handle those missing values. Missing value can be in your categorical object. It can be in your numerical. So then you will decide how you can handle it. Okay. Which method you are going to use for that, we are also going to discuss in upcoming slides about it. Okay. The second thing you need to do in data cleaning is data inconsistency. You will check for, like you have already handled the missing value. If there is any data inconsistency, what is that? We are going to discuss in upcoming slide because we will discuss example one by one for each step, right? So these are two steps you need to perform. And once you perform these two steps, first one is explore of the data, then data cleaning. The third step, now your data is handled with the missing value, inconsistency. Now your data is clean. It's a time to convert into the machine language, means numeric. If you have a categorical, you will take action on that. You will use some inbuilt method, that is one-hot encoding or ordinal encoding, to convert your categorical data into numeric. And then you will also handle the numerical data by scaling. Why we need these steps? We will discuss it again with the example. Okay. And which methods are these? So these are the three main important steps.
Drizzle.
These are the three important steps, right? You need to perform during your data preprocessing. Now we are going to discuss it in detail one by one. Anybody have any question? Okay, take your time. If something come up in your mind, you can post your query in chat as well. Okay.
Can I ask a question real quick?
Yes, sure, Sam.
If you have missing values, sometimes isn't it okay and part of the use of machine learning is to fill those missing values? Like, I mean, say you have a data set and you're saying like a third of your values are missing.
Mhm.
Isn't it like, don't you build a machine learning algorithm to try to figure out how to impute those values? You know, I mean, isn't that the point? I mean, just to fill it with the mean or the median may not be as precise as a machine learning algorithm or something like that. Is that something that is done?
We are going to handle the missing value using these strategy.
This strategy, okay.
Yes.
Just for our
Yes.
purposes.
Yes, but you will decide which strategy you are going to use. Mean, mode, median. There is some reason behind that. When you should use a mean, when you should use a mode and median. Okay, this is decided by you.
There definitely are more complex ways of dealing with missing values and other data types that we don't cover in the stack, like time series. Date time column, we might handle differently, some of those types of things. But for this assignments and for what we're sharing with you as far as using sklearn, simple imputer, and pipelines, definitely this is the most convenient way, and you'll use most often. If it's a very small amount of the data set, 2%, then using the median or the mean is not going to have a great impact.
Mm.
If it's 95% missing, well, maybe we shouldn't keep the column at all.
Fair enough.
And so just to add to that, so Harry says under the export data that if you found missing values in target, you should drop them, right?
Yes.
Okay. So we're not gonna fill the target with mean, median, or mode. No,
No.
It's not really. Okay.
Okay.
And so only if data is above 10-15%, then we should use mean, median, mode to impute. Otherwise, if it's 2%, then it's just let it go.
See, it depends, right?
Okay.
As per my experience, I would never prefer to delete the data directly, right?
Okay.
If it's a 2%, 5%, 10%, you need to think a lot. Maybe those, if there is a one row only, that we can do. But if you are looking at a data set, you have a 5 missing value, but maybe those 5 points are also important for you. You want to handle them, right?
Mhm.
It depends upon the situation and your business problem.
For sure.
Okay. So as we have discussed the pre-processing steps, now we will discuss it in detail one by one. What is that, right? First of all, we will talk about the how you are going to handle the numerical missing data if you have, right? If you look at this table contains number of advertisement and number of total sales, right? You don't have any value here. This is missing, right? So what you will do now, in this case, you are going to decide first which strategy you will use for this kind of missing value. Right now you have a numerical data, right? You can use mean, mode, median, right? We use generally mean for the numerical data, right? But if you are looking for some time, there are values maybe there is a difference between the values lot in that case, or maybe some value is occurring many times in your feature. That time you will use mode. And there is a median as well, right? Median you use when you are really care about the outliers, right? In that case, we use a median. So it depends upon your requirement and situation, what type of data you have, what type of business problem you have. So you will decide, I'm going to use this strategy for my this feature, right? And I'm going to handle it using simple imputer. In Python, how you will write it? Using this method. This is in Python. Simple imputer is the best and fastest way to handle the missing value in your machine learning. And you only need to use the parameter strategy, and you will pass value mean, mode, median according to your business problem and solve the value. If you look at this, I have used the mean, then it will take the mean of all your this column and fill it with that. So this is the way you will handle the missing value in numerical. You like whenever you are doing in your core assignments, like I'm using the mean, mode, median, in that case, you need to justify why I am using this strategy. Why did you use the mode or median instead of mean? You need to write the reason in your notebook. This is very important because this step is also in your BELT exam rubrics as well. If you are not going to justify why you use the mean, why you use the mode, why you use the median, your marks will be deducted. So make your habit from your core assignments. You are going to do the first assignments of the first week. So try to make your assignments as much as professional, your core assignments as you can. Okay. So justify the result, why you use the mean, why you use the mode and median. Okay. So this is the way how we handle your numerical missing data in your data set. Anybody have any question?
Yes, this is a quick question. So say for instance that maybe we were, getting data for people that range from like 5 feet to 6 feet. And most of the people that we got were, let's just say 5'4", I don't know, whatever. And then in that case, would we use like, well, hey, is that a way that we could justify like, hey, let's use the mode, the most documented heights 5'4", as a way to like, hey, well, I chose 5'4", not the median, because most people that was in this data set was like 5'4". Would that be a good suffice explanation?
In this kind, like as a layman, like this is a example is okay. But technically, when you want to define it, you need to give the reason like that. If I am using the mean because I found there is a no big, I want to take the average of the numbers, right? For this, because this is in the continuous form, nothing is repeating in that, right? And I don't care about the outliers right now, so I will use the mean, right? Mode, mainly we use rare mode function in numerical. We mostly use it for like categorical, that is we call in that case most frequent. And median we use when you really take care about the outliers. Then you will choose the two numbers, take the average of that, and then fill the missing value for the next one. Okay. So technically you can define the justification like this.
Oh.
For the numeric features, to really simplify it down, if the data set or that column is not skewed, mean and median will be the same. But if there is skewed, then we may want to choose the median.
Okay. All right, we'll do.
Okay, good.
Thank you.
Now we will move ahead with the next example. So this is our categorical example. If you found any missing value in categorical, how you are going to handle that? We will use if you look at this table, this is a model of the cars, right? In this, you have a Ford, Kia, Ford, Tucson, BMW, Kia, right? If it's a categorical data, we use the most frequent strategy in this case, right? Because this is not numeric data. We are looking at the value which is most oftenly occurring in that feature. And we will fill the missing value with that one. Okay. So after using this strategy, your value will be filled with this one, which is occurring most of the time in your categorical feature. Method is same, parameter name is same, your value will be changed. And in case of numerical, we have a mean, mode, median, and in categorical, you have a most frequent strategy. Okay. So this is a way how we handle the missing value in categorical data. Okay. Because you have learned the data in your first tag, how many type of data you have. Can anybody tell me what are the data types? How many type of data we have?
A float, string,
Hmm.
integer, boolean,
Mhm,
and then I guess object and string are kind of the same thing.
mhm.
Yeah.
Okay. So basically you have numerical, right? It contains your float, integers, numbers, right? And then you have a categorical, right? Categorical further divided into ordinal and your other one nominal, right? So these are the data types you have learned, right? Can anybody tell me what is the difference between ordinal and nominal? Anyone?
Is it like ordered by class and numerical by number? Sorry.
Yes, Diani, yes. You can give any
Continuous?
continuous, no. Continuous is number, right?
Ah,
Numeric data.
Yeah.
So if we are talking about the categorical, right? I will make a one table here. So you all can guess what is this. Is this nominal or ordinal? Low, high, medium. So can anybody tell me, is it ordinal or nominal?
Nominal.
Nominal. Anyone else?
Well, this is ordinal, right? Because it's low. So there's 3 levels to it.
Yes.
There's an order
There's
to
an
it.
order to it. Yeah.
Yes.
There
Right.
are-
Great answer.
Group by brands. So that's yeah.
Right. If I am giving this female, male, is this nominal or ordinal?
That's nominal, right? There's no order to.
Nominal.
Yes, it's just naming, right? So this is the difference between your data type. So you have a 2 type of data in your data set. This is further divided into parts. Okay. Okay, good going. Now we will talk about, till so far we have seen about the data pre-processing steps. Then we have discussed how you can handle the missing value if you have a numerical data. How you are going to handle the missing value if you have a categorical data. Now it's a time to look at the inconsistency which we have discussed. These steps you need to do. Okay, one question I have, which you have seen in the previous 2 slides, and I have a handle consistency next. Are you going to perform these steps before split or after split?
I think it's after, correct?
Yes, right? Whenever you are taking the action on your data set, you are handling it, you are making a changes in your data set, that all steps should become after data split only. Okay. So in this, we will talk about now handling inconsistency. In this, what is that? If look at this table, it's a gender column. You have a male, female, male, female. But if you look at it carefully, this male is starting with the title M, right? Capital M. But if you look at these, the value is the same, but its first letter is not in caps, or not in like in the form of title. It's a small, right? Again, if we look at the female, it's coming with the title letter, but it's not, right? So this is kind of data we call it inconsistency in your data set. Okay. So how you are going to handle it? we can handle it using dictionary. Okay, this is a one way, dictionary. So in this, what we will do, you will declare the column name, say male, you will change the value with the capital M. Again, the small female with the this one. And then you are going to replace your gender column with this dictionary. Okay, then you can look at the result. Now it's your whole column become a consistent. There is all your first letter are a title one. There is a no small letter. So this is the way how you handle the inconsistency. Okay, this dictionary method is the best way. Okay, when you want to handle the inconsistency in your this type of like column, right? But there are two like nominal, like the, you can say you have a values, male and female, right? Categories, only two. But maybe you have a more, right? So whenever you have a more, carefully replace it. Okay. So now we will ahead with the poll time. It's a poll time. Anybody have any question before I open the poll?
I didn't understand the last part. You said that if it's more than, were you being specific to male and female, or was it if there's more than two? And
Can we? No, it's not specific to male and female. You may have the more categories here. Like let's suppose you have any other values added in this. It's a female, right? You may have a kid section as well in this, right? Boy, girl, right? So you may have a more inconsistency in that,
Okay,
right?
so don't use the first gender under call. Use the DF gender. I'm sorry. I guess I'm trying to understand what.
No, I'm saying whenever you use the dictionary, use it carefully. Okay.
Okay.
Yeah, this is what I'm saying.
Okay.
Method is the same. Okay, because sometimes you have a more than 2 categories. You have a 10 categories, you have a 8, you have a 5. Okay. And then it's a poll time. Which is the fastest and best way to handle missing values? Good. 2 more responses are left. So the correct answer for this question is simple imputer. Okay. I understand you all have learned a fill now method in first tag, but you are not going to use that anymore in machine learning. Okay. So here I would like to add one thing more. Whenever you are doing your core assignments or you are doing the practice or project 1 core 5, okay, if you found any missing value in that, you are going to use now simple imputer for that. Okay, and don't try to fill the missing value before split using fill now method. Okay, this is incorrect. Why? You will come to know in a few minutes. Okay, you only need to use this method after data set split. That's it. Okay, don't use this one. Okay, it will cause data leakage if you are going to use it before split now. Okay, this is the reason. You will understand when I will give you the example. So till so far we discussed about the how to handle the missing value using your fastest and best way inbuilt method, that is simple imputer. Now we will talk about the transformation steps. which I have shown you in the first slide. So the first step is you are scaling the data. So why we need to scale the data? Okay, first we will discuss that. Now look at this table. Here I have a 3-column name. This is the name of the fruits, and this is the weight, and this is the price, right? But if we look at the weight, their magnitudes are very high, right? Then prices, right? So there is a huge difference in the units, right? So what will happen? If I will give a layman example first here, if you go to the market, right, you saw a variety of the apples, right? But if you know what type of apple and their attributes which suits you, this apple would be good for me. It will take very less time for you to buy those, right? If you don't know what type of apple, right, you want to buy, you don't understand, then it will take time for you, right? Instead of spending only 5 minutes, you are going to spend maybe 10 minutes or 15 minutes, right? You need to do a hard work there to learn that which apple is good for me, which is not, right? So the same thing is here. When your data set have like these values, one feature have a higher magnitude value, other is a low. And when you will fit into the machine, this data, your machine will take time to learn from this, okay? Maybe this weight feature dominates this feature because of high magnitude in values. This is the reason. So your machine may not learn in a good way. Your machine may think, I should give the more weightage to this because its value is high. Maybe it's important, but it's nothing like that, right? We know all features are important, equal importance, right? But your machine maybe takes time to learn as well. And this feature with the higher magnitude may try to dominate this feature, okay? So that's why you need to scale the data, okay? And we always scale your numerical data, okay? And in this, you use inbuilt method that is standardization. You will import the library from the sklearn, create the instance of this, and then scale the data, okay? That's why we need to scale the data in machine learning, okay? Does it make sense? Anybody have any question? This is very important to understand these things because you are going to use these all steps throughout the stack. Okay, so I will give you one example here. Look at this picture. This is your features, right? So in this, if you look at this age column and salary, huge difference in the units, right? But when you apply the Python method, the standard, your scalar method, standard scalar method, it will convert your data like in this form. Okay, it will, in scaling, it will set some range. Okay, it will make the mean 0 for all data points and standard deviation to 1. So your all values will be within that range. That's why it scales your data and it will help your model to learn correctly. Okay. So that's why we scale the data. Okay.
I have a question.
Mm-hmm.
What if we actually, based on, let's say we have a data set and we want one column to have more weight than the other 5 columns? Is there a way to do that? Or do we have to make all the 5 columns weigh the same?
So you are saying, like what I understand, if you want to give the specifically, you want to give the weight for one of the column, right? Rather than the other column.
Like
right?
I feel like if I want to give, I want salary to have a higher weight on the machine learning, you know, than the other columns.
Okay. But like, first of all, I will, it is not the, I will say good practice, not the correct way. Because I have given an example earlier, few minutes ago. In that case, what will happen? Your model will take time to learn and your model will not give the preference to other columns. Your model may think, your machine may think, this is a higher magnitude. Maybe I need to give the more weightage to this.
Okay.
And your
Okay.
this column will dominate other features. So in
Okay.
that case, what will happen tomorrow? Its prediction will not be too correct, right? And second thing, when you will give the new data set, right? New test data set, it will not perform good in that case as well. Because your model did not learn correctly, right? Its prediction may affect your results.
Okay. Okay.
Okay. Yeah. Okay, it's again poll time. And should we scale the data set? Good, good, good. One response is left. Good. The correct answer to this question is after data set split. Okay, because this is a, we are going to scale the data, right? And you are going to scale the data after doing everything. Okay. Now, we will move ahead. Now we will talk about the second transformation method, right? Encode the data. First, we have talked about the numerical data, right? Now we will talk about the categorical. What is encoding? You have a mixture of data types in your data set, categorical and numerical both, right? If you have a numerical data, you only need to scale it. You don't need to do anything with that. If you have any missing value in numerical, then you need to take the step. Otherwise, you only need to scale it, right? Nothing to do more than that. In encoding, if you have a categorical data, if you have a missing value in that, first you will handle the missing value, and then you need to convert the categorical data object type into numerical. So your machine can understand, because your machine does not understand English language. It only talks in the form of numbers, right? So here in coding, you have a two type of methods in that. First is one hot encoding, OHE. Okay. Another is ordinal encoding. Okay. Ordinal encoding, we are going to apply on the ordinal data, right? Which we have discussed a few minutes ago. What type of data is ordinal? When you have a, in the form of order, the values, categories, low, medium, high, 1 star, 2 star, 3 star, 4 star, they are in the form of order, right? And one hot encoding, when you just have a numbers like female, male, you may have a other classes, may like the examples, like name of the, your, let's say you have a fruit column, you have a number of fruits over there, right? Like that. So how you are going to encode the data? Now look at the example. So our first example, this one, right? So this is nominal data. In this, I have an ID column and color. In the color, you have a red, blue, green, blue, right? This is nominal data. So when I will apply, when you have a nominal categorical data, you are going to apply one hot encoding on that to encode it. Okay. One hot encoding is an inbuilt method in Python. Again, you will see in the code along. Okay. Don't worry right now about this thing. So once you applied it, it will create a number of columns according to your category you have in that. Okay. So I have here red, blue, green, 3 categories, right? Because blue is repeating. Okay. So I will not count that. So unique, how many unique categories I have in that? 3. So your one hot encode, what it will do? First, it will create a number of columns according to these. If I have a 4, let's suppose if I don't have a blue here, yellow, then it will create one more column. Yellow. Okay. And how it will convert it? At first place, you have a red color at ID 1. So what it will do? Under this column color red, it will mark it 1. Rest all categories will be 0. Okay. And if you have a blue, it will make a red 0 at that place, green 0, and blue will be 1. Okay. You don't need to worry about it because this is automatically done once you apply the one hot encoding in that. We are just discussing what will happen, how it works at the back end. This is the way how it works. One hot encoding. Okay. Now, again, I will say whenever you are using the one hot encoding, for the categorical data, you need to justify why you are using one hot encoding instead of ordinal encoding. What is the reason behind that? Okay. Can anybody tell me what reason you will give? How would you justify when we should use one hot encoding? Anybody? I just mentioned it few minutes ago. When
Because
you should.
So also there is no order to the values, right? So that's why we use one hot encoding.
Yes.
Yeah, there's no like leveling to it. Red and
Yes.
blue independent, yeah.
Yes. When you don't have ordinal data in categorical, then you use one hot encoding, right? For nominal. And if you look at this example in this table, what is happening here? Here, I have a low, medium, high. High is repeating, right? So we can use here 2 ways to convert it into ordinal encoding. Either you can use the dictionary like the same way, low, 0, then medium, colon, 1, and then high. Okay. So you can use the dictionary method for this one, okay, to convert it into encoded form in numerical. And second way is your ordinal encoder library. Okay. So you can also use it. I will show you in the code along. Okay. So you have 2 methods to handle it. This is your choice. I would recommend if you have like more than 5, like your categories in ordinal, right? Then go with the ordinal one. Okay. You don't need to change it manually using dictionary. If you want, this is your choice, but you have both option. Okay. So this is a way how we handle numerical data, how we handle categorical data. In case of missing value, in case of transformation. Okay. So you need to justify. This is a slide I have given the example. If you all want to go through that, how you can like justify the results, why you are using ordinal, why you are using one hot encoding. Okay. So again, over time. Wow. Everybody give the correct answer. Okay, good. Okay, now we will move ahead with the most important topic, that is what is data leakage and how it happens, right? As I have told in the start, never ever take an action on your data set to handle missing value, to make any transformation before data set split. Okay, so this is just because it will cause the data leakage. Okay, how we will discuss now. Look at this diagram. The first step, very first step is this. We will load the data set. Then we have discussed in the first lesson as well, you need to make a copy of the original data set. Okay. So the reason behind that, we don't want to touch the original data set. I don't want to make any changes in my original data set. Okay. After that, what I am doing, I'm just applying the I started applying the pre-processing steps, right? Like looking at the missing value. If I found any missing value, then I use the fill the method, maybe simple imputer method, but I did not split it yet. Okay. Because when you are doing the pre-processing step, there is a one step coming between visualization, right? Before your split. So sometimes you may think there is a lot of missing value when I am exploring the data set. Let's fill it first and then make a graph, right? And we use fill the method. Don't do that. Okay. Whenever you are like plotting the graphs, your matplotlib doesn't care about the missing value. Okay. If you want to do it, right, the correct way is use this copy for your one part for your visualization and you make another copy for your machine learning pre-processing in that case. Okay. So although this is additional information which I'm giving right now, let's come back to here. So if you apply the pre-processing steps before split, what will happen? You have already handled the missing value, right? You did everything here and then you are splitting it. What will happen now? Some of the data, some of the category may be shared from test to train now, maybe train to test now, right? So what will happen if your trained data have some value, some category, some any class lie in train as well and test as well? Your trained data, your machine is already knowing you about your test data, right? You are already sharing the information. So when you come at the stage, you are going to evaluate your model will perform very good. You will be very happy. 99% accuracy with my test data, trained data, right? You feel like, oh, my model is doing good, right? But what will happen when you have a new test data? Your model is going to be fail, okay? Because when you are going to train your machine, you already shared the evaluation testing data, which should not be supposed to be shared, right? So this is a mistake. So this is happening, the data leakage here, because we are, why? Because when you handle the missing value here, right? After that you are splitting. So some of the information will be shared here after split. Does it make sense? Any question? This is very important to understand what is data leakage, why we should not handle missing value before split. Okay.
Mayor, I got one question. I see the EDA_DF. I've seen this a few times now. What does the EDA stand for?
EDA, I just make it the general name. This is exploratory data analysis. You can name it with any name. This is not specific. Okay. Because I'm going to use it for pre-processing. That's why I name it with EDA. Okay.
We may want to distinguish between the raw data, which we might leave as just DF. And then if we want to impute values for our plots, we can do that, but we don't want to do that for our machine learning models before train test split. So we might create an EDA DF and an ML DF. So the ML_DF, we would not want to do any imputing or anything like that, handling missing values before the train test split. But for an EDA DF, we could. Does that help?
Yeah, that helps. I guess I didn't know what EDA stood for.
Exploratory data analysis or explanatory data analysis.
Thank you.
Mm-hmm.
Okay. So if this is happening, the data leakage here, how you can avoid it? Okay. So now look at this diagram. So in these, which steps you need to follow? You will load the data set, right? Then you will make a copy of the original data set. Then you will split it. Okay. Before that, only you can explore it, which we have mentioned, which we have discussed in previous slides. But after that, you split it. You will apply all steps like handling missing value, transformation methods on these train and test, and then you will fit onto the model. Only the training data we fit to the model, not test. This is used for only evaluation. Okay, so this will help you to avoid data leakage. So here no information will be shared with your train and test. Your test data will always be hide from this. Okay, so this is the reason we always need to split the data set to avoid data leakage. If anybody have any question about the data leakage and the steps till so far, please feel free to ask before I move ahead.
So I understand that if you were to find the mean, median, or mode, that would classify as data leakage. But how is it that when you drop a column, that would affect the test set?
Can you repeat your question? Like if you are using the mean, median, mode, that is causing the data leakage before split, if you are doing that, right?
Yes.
And I did not understand your drop one point.
So if you drop a column, how does that affect the test set? Like, how does that affect the data in any way?
Okay, if you drop it before your split.
Yeah.
No, if you are dropping before split anything, any records, it is not going to cause any data leakage. Okay, but if you are handling it, like what will happen? This is your whole data set, right? So you have a number 1 column, 2, 3, 4, right? If there is a 1 missing value here and 1 is here, right? I did not split it yet. This is my whole data set. If I'm going to handle it, if I drop anything here, I don't, although we never drop, we drop the feature if it is not required, but we try to drop the only row wise. If it does not making any sense to us, or there is a 1 record missing, then it will not affect your data leakage if you are doing it even before data set split. Okay, but if you are using mean and mode here, right? You are filling missing value here. Let's suppose it filled with 10, it filled with 5, right? Now I am splitting it. What will happen? This information maybe goes here already, right? And your trained data already know the answer of this thing, right? So this is going to cause the data leakage, but dropping is not going to affect. Does it make sense, Joshua?
Yeah. Yeah. Thank you.
Okay, this is one more example how the one hot encoding can cause your data leakage. Okay, in this, let's suppose when you split the data, your data, there are categories in nominal column that are present in the test, right? But not in the training set, right? This is we are talking about when you split the data, right? But what will happen if you apply the one hot encoding before split? Then some information may be shared from your test to train. In that case, as I have already given the example a few minutes ago, this is the same thing. So that will cause the data leakage again. Okay, so that's why this is highly recommended. Every step you need to take separately after data set split. Okay, now it's a poll time. Okay. The correct answer is after the split of data set only. Okay. Now we will move ahead with the another most important topic, that is pipeline. Okay. Pipeline you use when you want to apply many transformation on same column. Okay. Then at that time you use it. Okay. I will give you the example here. If this is the, okay, we will move ahead with this next slide. I have a diagram over there. Okay. So in this, you have a number of rooms here, right? So this is your one of the feature. Here, what type of data is this?
Numeric.
Yes. And what kind of transformation we need to apply if we have a numeric data?
It'll be standard scaling, right?
Yes, correct. Right? So in this, right, I need to apply, if we look at this carefully, there is a missing value as well, right? So I need to apply a two transformation here. First one, I need to handle the missing value. Second thing, I need to scale it, right? So you are going to taking the two actions on the same column. When you want to do that, you will use the pipeline. This is very fast. It will like make your pre-processing very, very fast. Okay. So what you will do, you will make a pipeline with the name of num_pipeline, right? You will add the impute missing strategy in that and scaling it. And then see the result. You don't need to do it separately. Okay. But you need to take care of one thing. Whenever you want to apply more than one transformation on the same column, then only use a pipeline. If, let's suppose, you have this table, then do you think you need a pipeline then? Right?
Well, then you only need to do one thing, right? Just standardizing it. You don't need to do any imputation.
Yes, great answer, no, yes, right? So this is a picture how it look like in the Python. Okay. So the same thing for our categorical pipeline, right? In categorical again, this is a missing value. I need to apply the simple imputer on that, right? And also I need to apply one hot encoding because I want to convert my categorical data into numeric, right? So that's why I need to apply two transformation on the same column. So I will use the pipeline again. Okay. So you need to take care of this thing. So at what step you will decide, are you going to use a pipeline or not? Anybody? When you are going to check the missing value?
After the split.
No. When you are going to check the missing value again? You can do after split, but we have discussed before split, right? You are going to check missing value before split. You are going to handle missing value after split, right? Yeah. So at that time, you can decide if there is a no missing value, I need to apply only single transformation. So I don't need the pipeline. Okay. So you keep your mind open at that time from the initial level and then use it. Okay. Does it make sense, the pipeline? Anybody have any confusion in the pipeline? This is very important. You are going to use throughout the stack. Please feel free to ask if any confusion.
I think I'm a little bit confused because the way that it was explained, it seems like we don't need to use a pipeline if we're going to be dealing with missing numbers before the split. And then we use either one hot encoder or standard scaler after the split.
You are saying if you are going to handle missing value before split?
Yeah, isn't that what was said earlier?
No, you are not going to handle missing value before split. You are only going to check missing value. Okay. If you think like, let's suppose you have a data set. You use the ISNA method to check how many missing value you have, right? You found 0 missing value in your data set, right? In that case, you already know I don't have any missing value. It is already filled. So your column is like this, right? So you are left with only scaling the data, right? So you don't need a pipeline for that because you only need to perform one step, right? On the column, you only need to scale it, right? But if we take a other case, if you are checking the missing value and you found 2 missing value, 10 missing value, right? In that case, after data set split, you need to use a simple imputer strategy as well. You need to scale it as well, right? So you need to perform 2 steps here. In that case, you need the pipeline. It will fasten your pre-processing steps. Although it's nothing wrong if you are not going to use pipeline, but what will happen? It will take time, right? And you need to apply different methods. Sorry, not different methods, separately. Does it make sense, Amber?
Yeah, got it. Thank you.
Now we will talk about the column transformation. So first we talked about the pipelines. If you want to apply the more than one transformation on the same column, we use pipeline. Column transformer, we use when you want to apply the transformation at the same time on different columns. Okay. So it may contains your numerical categorical together. Okay. Inside column transformation, you can have a multiple pipelines. Okay. And inside pipeline, you can have a column transformer. They are vice versa. Okay. I will show you in the diagram. Its syntax is this. Okay. Make column transformer. It take the array of categorical tuple. What is that? This is your first pipeline for the categorical, which we made in the previous slide. This is your numeric. And this is your remainder third parameter. It come up with the value of drop, right? And pass through. Okay. This is very important to use. Why we use this remainder third parameter in the make column transformer? Because you may have, when you train your model, you tested it, evaluate it, right? Tomorrow you have a more new data. In your new data, you may have any new category which does not lie in your trained data, right? It may change from the previous data. In that case, if you are using this parameter, your model will ignore that one. If you are using drop, it will drop that new category. If you are using pass through, it will ignore that. Okay, but it will never throw error. Okay, that's why it's important to use. Okay, does it make sense? Any question? Okay, let's have a look at the diagram. So these are the pipelines which we have made in previous slide. This is for our numerical. This is for our categorical. Okay. And this is called, if I go back to previous slide, categorical tuple is this one. Okay. This is the array. Okay. So it will contain the combination of your data like this. Let's suppose you made the categorical pipe with this name, cat underscore pipe, right? This pipe contains the combination of 2 transformations, simple imputer strategy plus your one hot encoding. And then you have a categorical data here. Okay. This will become the array for your column transformation. Okay. I will show you in the code along. Okay. And then this is the third parameter. This is how it look like in Python. Okay. You will have a more understanding when you will see in the code along as well. And this is, I already mentioned, like inside pipeline, you can also use a column transformer. Okay. So they both are a vice versa. Okay. Does it make sense? What is the difference between column transformer and pipelines? Anybody have any question? Take your time. Okay, you can stay after office hours as well. This is the 5th question. Good. One answer is left. One more response. Okay, the answer to this question is need to apply many transformation on the same column, that is called pipeline. Okay. And this is for your next week learning. Okay, you are going to learn about linear regression with the pipeline, evaluate regression model, and compare the fitted model performance to a baseline. Okay, this is we are going to cover up next week. And today we have covered pre-processing steps, data leakage, column transformer, pipelines. Now we will move ahead with the code along. So this is the first step. You will first import the libraries which is required. Not all, which is required. Okay. And after here, I will import pandas, numpy, your model selection, train test split, which we use to split your data set. This is your compose package from sklearn. We are importing the library, make column selector, make column transformer, right? And then pre-processing steps, standard scaler, one hot encoder, ordinal encoder, right? And then pipeline, make underscore pipeline. Simple imputer from the impute package, which you are going to use handle missing value. Okay. And then set config. This is very important. If you are going to use this, you will never have a confusion in simple pipelines and column transformer. This is highly recommended to use it. So you can see the flow of the pipelines and the column transformer. Okay. So here we are going to take the data set of diamond. We want to predict the sale price of the diamond based on the measurement of the diamond. Okay. What features you have? You have a weight of the diamond, quality of the diamond, color of the diamond, clarity measurement of how clear the diamond is, your length, width, depth, right? So can anybody tell me what type of data is this?
Ordinal?
Great, yes. And what type of this?
The same ordinal?
Yes. And these?
That would also be ordinal?
Okay, so first we will load the data set, right? And look at the data set here. Okay. And if you look at this column unnamed, is this useful or not? No. Can you tell me the reason why not?
Because it hasn't been.
Yes, right? It's not going to make any contribution. So we can straightforward drop it, right? And in this, first of all, we will make a copy, right? So we don't want to touch the original data set. to avoid any kind of data manipulation or data leakage. And then we will drop this column, right? Axis 1 is equals to column wise. Okay. And then we are checking the missing value here. You got a lot of missing value, right? So if you are getting the missing value in numerical, what type of 2 transformation steps you are going to do? Will you use the pipelines here for this kind of problem? Anybody?
Wouldn't you use like the one hot one to convert some of these ordinal data things like color of the diamond into numerical things, values?
Yes, for categorical only. One hot encoding and the ordinal encoder. You are
Yeah.
right, Sam. This is one transformation, right? We
Yeah,
have a,
and you do that though, so because it's easier for the computer to interpret the data, correct?
yes,
Okay.
right?
Yeah.
And then we will check the duplicates. We have 145 duplicates, right? As you have learned in the first slide, we are just doing the before split steps, right? You found the duplicates, you will drop it. It is not going to harm any your data or not going to cause any data leakage. Okay. Then look at the information section. It is telling you the number of records, type of data. You can also look at if there is missing value. Okay. Describe section will give you the statistics of each feature. What is the minimum value? What is the maximum value? Interquartile range, mean, standard deviation. Okay, this is very useful. And then we will drop the rows with no price. Okay, so this is what I have mentioned in the pre-processing step before split. If you found any missing value in your target, drop it. Okay, we are not going to handle the missing value for the target one. Okay, so in this, we have seen in the price, you have a 6 missing value in target, right? So we will record those records from your data set. Okay, so you can see now, this is the like how useful to check the missing value before split. And then we are just checking how much percentage of data you lose. 0.1%, right? Now we will drop the target column from your X features here. Okay, and then we are setting the Y. Here we are using the train and test split, right? Test size 0.30 means, what does it mean? What will be the split size?
70-30.
70% for
The train, for the train one, the X, and 30% for the test, that's the Y, the target.
and great answer. Yes, right? Random state because we want to look at the consistent result. Okay. Now we are just looking at the categories. How unique categories, the count of that. Okay. Here you will select the X train dot select D types include is equals to object. We will run the loop on the categorical object type columns, and this is the result. So ideal, you have a count of this much, premium, very good, good, fair. Same with the color and clarity. Okay. Now come here. So you have seen, you have a missing value as well. You have a numerical data, you have a categorical data. If you already decide, I need to apply the transformation on that. So what steps you need to do? For numerical data, we will declare standard scalar, right? As we have discussed. This is the your object for these to scale your data in bit standard scalar. We will create the instance of this. Then one hot encoder. Okay. Sparse is equals to false to avoid the zeros in that. Handle unknown, ignore. This is kind of any error in that. And then simple imputer strategy, we set it for numerical data. Mean, most frequent, we set it for categorical data. Okay. And then this is for third simple imputer strategy, constant. Like this is the constant value. We are filling the value where with the missing word. Okay. So this is the third strategy. Okay. So now come here. So this is, first of all, you will separate the ordinal data type from your data set, right? You will separate it from your data set. This is your cut labels, clarity labels. Okay. Now you will make a list of both. Okay. You will like collect it in a one list, and then you will declare the ordinal encoder library, right? Which I have told you in the slides. If you have a 1 or 2 or 3 categories, right, you can use the dictionary to convert it into numeric, the ordinal data. But if you have a more categories, maybe more than 5, 10, right, you can also use ordinal encoder. This is the inbuilt library to convert your ordinal data into numeric. Okay, so it will automatically convert your these two columns into numbers. 0, 1, 2, 3, 4. Okay, according to your unique categories. Does it make sense? Okay, so now we will make a pipeline. Why I need a pipeline? Because I need to apply a more than one transformation. For numerical mean imputer, scalar. Frequency, most frequent imputer for ordinal. Okay, and missing imputer and OHE for nominal. Okay, and then we will here mention your column list for your objects and number selector. For nominal, I have a color data type, and for ordinal, I have a cut and clarity. Okay, and to separate your numerical data, you can use make column selector. You can also use it for object type as well. It is not only meant to be for numbers, it is also meant to be for object. But I am not using for right now D type include is equals to object, because I wanted to separate my from categorical, ordinal and nominal both. That's why I'm not using it for right now categorical. Okay, so you need to separate it manually, because there is no method using this. You can separate the nominal or ordinal. Okay, it will only separate categorical together, which includes nominal, ordinal both. So you need to do it manually. Okay, and then we will prepare the tuple for column transformer. Okay, here you will, as we have discussed in slide, num pipeline. What is the combination of this one? For the num pipeline, this is, it contains your two steps. First, it will fill the missing value in your numerical feature, then scale it. This is two transformation it is doing on which numerical data. So your tuple is a combination of your data plus transformation steps. Same for the ordinal and nominal. Okay. Now we will use make column transformer. We will create an instance preprocessor. From this, pass the all tuple inside it. And remainder is equals to draw. This is your choice. You can use pass through as well. Okay. This is not like mandatory to use draw. And then we will fit onto the X string. Okay. Here you noticed I'm only using the preprocessor to fit on X string. X string is your raw data, right? But preprocess contain your all steps. Look at this. This is column transformer. It contains, this is your first tuple, ordinal. This is second tuple. This is third tuple. Okay. That's why I was saying, if you use that set config diagram one library, it is easy for you to understand the pre-processing of column transformer and pipelines. Okay. So this is the way how you fit onto the X train. Once you fit it, you will transform the X train data and X test. Okay. And now this is the result. So your whole data set is converted into numeric Plus you handle the missing value in categorical and numerical both. Does it make sense till so far? Any questions from here?
What do you transform when you only fit the one?
Daniel, can you repeat? Your voice was breaking.
Yeah. Why do you transform both of them
Mhm.
if you only fit the one?
Yes, you are right. We only fit onto the train. We never fit onto the test because we want to evaluate over data, right? So your test data will only be transformed. So whatever you have any like categorical, numerical, you want to scale it, you want to convert it into numbers, that's why you need to apply the transformation. But fit means your data is your model is learning from there. Okay. So when you will see in the next week the model, how the model will fit, you will more understand this thing. Okay. We never fit it onto the test data. Otherwise, it will know everything. Okay. So this is only fit here and then transform. And you need to take care. This is very common mistake. What the students do, they create an instance of make column transformer till so far they good to go. But sometimes we forgot to fit use a preprocessor. We directly try to fit something with the model, which I show you in the next week, what the mistake can happen. So this step you need to use it very carefully. When you create an instance, you need to understand what does it mean. What is the difference between this one and this one? Xtrain is your raw data. Preprocessor contains all steps which you need to apply on train data. Transformation, handling missing value, everything. Okay. Anybody have any question? Very quiet. Any confusion? Take your time. We have a time. Okay. This is optional. This is we are going to do in the next week. If you want to like look at it, this is model fitting, but I will explain it next week. Okay. If you want to do something in like the after office hours, this is a question. Should we scale ordinal data? If yes, please write the code for that using pipeline. Anybody can tell me, do you think we need to scale the ordinal data? Anybody? Okay.
I mean, does this or ordinal data comes from, was it a categorical variable that got transferred into ordinal?
Yes.
Oh, that's a good question. Well, I guess, yeah, otherwise it would give more preference to that column than the standard scalar. But then, oh,
No,
that's,
yes, no, you are right.
oh, okay. Hey.
If you have a categories, like maybe you have a 2 or 3 categories, then it will not affect, right? But you may have a 10 or 20 categories. So your magnitude of that column is going to be high, right? In that case, scaling is very helpful.
And
right?
same with one hot encoding as well, right? Because you have 0, 0, and then 1, and then 0, right? So we should standardize that as well.
No, in that
No?
we don't need. Because
Oh.
this is not higher magnitude. This is only 0 and 1.
Oh, for sure.
Okay, I'm going to stop recording.